our ever-changing world is in constant need of new equipment to meet the standards of our coding capabilities. Physical computing has been the limiting factor in hindering our progress. Recent discoveries and innovative research involving replacement of metal cathodes with polymer substitutes has broadened our horizons, allowing us to make the jump forward, developing and ensuring the widespread usage of aluminium-ion battery sources. So join me as we explore how this unassuming yet powerful technology has the capacity to transform our energy storage paradigm, offering solutions to problems that have long impeded progress towards a cleaner and more sustainable future. The aluminium-ion battery, with its unique attributes, may very well hold the key to unlocking a new era of energy storage innovation.
Our project focuses on goals 7 and 9 of the UN Development Goals. There are some core properties of power grid. First, power generation. Technology is already being developed in the world of renewables. Solar, wind, hydroelectric, geothermal, solutions to generating power clean. Now, there is a need for this increased scale and efficiency of renewables as power plants go up. We use power for almost everything. Cars, laptops, phones, kitchen, appliances, light, heat. Power is an essential part of our everyday lives. The third part is power storage. A phone isn't much use without a battery because you need the battery within it to make it last through the day without being plugged in. The existing power infrastructure is very difficult to run through remote rural areas. And this is why we suggest batteries as a potential innovation. They're not the regular batteries, lithium-ion, hydrogen, or anything like that. We're suggesting using existing.
Our idea involves utilising aluminium-ion batteries to a fuller extent and on a more global scale. Introducing large-scale aluminium anode recycling, we plan to use aluminium waste from first world countries and recycle it into anodes for the batteries that are run using electrolysis reactions, and then distribute these batteries among lower income countries and help improve industry in these countries. Aluminium batteries typically have 8 times the run duration of industry standard lithium-ion batteries and weigh a lot less for the same power output. This will drastically reduce the current hassle involved with battery life and recharging. Another benefit of globalizing aluminium-ion batteries is that it will create another avenue for metal recycling and waste usage, causing the electronic industry to move away from the incredibly harmful mining of materials that it currently relies on. This idea also allows for avenues of development economically for countries and industry. The batteries are cheaper, lighter, and more usable in lower income countries than typical lithium-ion batteries. Aluminium-ion batteries are also typically safer to operate than lithium-based batteries because they are less likely to have thermal runaway and cause fire hazards. This makes them more suitable for recreational use in homes and small-scale projects in lower-income countries.
This is especially significant in rural areas where they are cut off from the rest of the energy infrastructure of the country, making this a significant development for them because then they will be able to run their homes off of this battery innovation. This technology is already used by the military, but it's not available on a commercial scale. We believe that there's a lot of potential here due to the many beneficial
properties of aluminium-ion batteries, as well as the existing application of these batteries within the military, proving that they're suitable under extreme environments that the military will be using them in, making them suitable for remote rural areas.
On a molecular level, 2 different reactions occur, one being at the anode and the other at the cathode. These 2 reactions seem like the opposite of each other. That's because they are. The anode ionizes the aluminium, whilst the cathode converts the ion back into its normal state. These reactions occur millions and even billions of times a second, providing our energy source, of which provides the aluminium-ion battery. So, what is actually happening in our system? Essentially, we have an electrolysis system in place. A cathode and an anode are placed at either end, composed of various different potential materials to choose from, of which graphite being the most common choice, with plenty of other more successful replacements still in production. Aluminium readily reacts to form a passivating oxide coating that is chemically inert, and an extremely high potential is necessary to push ions through this layer. This high potential would degrade the electrolyte during recharging. So the use of this ionic liquid as an electrolyte prevents passivation and allowed aluminium batteries to become rechargeable.
Aluminium-ion batteries would need to be mechanically recharged, meaning that the aluminium anode would have to be replaced every time it has been used to its extent. This means electricity is not required to recharge the battery, only access to a new anode is required, allowing for houses without mains connection to run electricity off the aluminium battery and then buy new anodes to recharge the battery. This will allow for more remote and less industrialised areas in third world countries to have access to the benefits of electricity without the need for access to mains electricity. Also, the need for mechanical charging creates a new industry in recycling the used cathodes, allowing for economic opportunities and sustainable growth, industry growth across the globe. Also, mechanical charging means there is an instant recharge time, and so the batteries have very little downtime compared to current industry standard lithium-ion batteries.